So, a very good evening to all. My voice is audible to all of you. Just confirm me once. Yeah. Just confirm me whether my voice is audible to all of you or not, right? And my screen is also visible to or not, right? Just confirm me once so that we can start our today class. Chalo. Right. Seems all good. So basically, in this class, what we are going to do now, we are going to quickly revise the all the important syllabus for the AIT examination too. So in today's class, we are going to discuss electrochemistry. So I'm trying to explain this chapter in a just a summary way or in a shorter way, right? And try to solve numerical related to this chapter, right? Because this is very important thing to solve numerical. Okay, so I'm going to quick revise this chapter for you, all of you, and then we are going to solve numerical related to this chapter. Clear है सबको यहाँ तक, right? So we are going to do electrochemistry today. ठीक है? चलो. So basically, what is electrochemistry? We all know this thing now. What is electrochemistry? So basically, electrochemistry is what is electrochemistry? That is interconversion of chemical energy and the electrical energy. So what do you mean by this term interconversion? Can anyone explain me? What is this term interconversion, beta? Interconversion of chemical energy in the electrical energy. Can anyone tell me what do you mean by this term interconversion here? Chalo. So interconversion means what? That is, we can convert chemical energy into electrical energy and similarly electrical energy into chemical energy. So this chapter is very important. That is electrochemistry. So in this chapter electrochemistry, we are going to study how chemical energy is converted into the. I got one response. Yeah, JNB Dahod. Okay, good. So in this, we are going to study how chemical energy is converted into electrical energy and how this electrical energy is converted back to the chemical energy, right? And the chemical change involving how? That is the flow of electric current, right? So JNV Visakhapatnam is also present. Very good, beta. Right. So chemical changes involving the flow of electric current are referred as electrochemical change. So they are basically referred as electrochemical change. Clear है यहाँ तक? चलो. Now, the next thing is electrochemical cell. So let's see the first cell, also known as the galvanic cell or voltaic cell, also known as the electrochemical cell, right? So this is the basic cell which converts chemical energy into electrical energy. So let's see how this cell works, how this cell is made up of, what are the composition of this cell, right? तो पढ़ते हैं एक बार फटाफट कि क्या कॉम्पोजिशन है इस सेल का, ये सेल किससे बना हुआ है, व्हाट इज और क्या क्या इसका इंपॉर्टेंस है, राइट? So basically in the galvanic cell, some spontaneous redox reaction takes place and they produce the electric current, right? So they produce the electric current. That means in this cell, chemical energy is converted into electrical energy. Now, the change of this chemical energy to electrical energy causes lowering of free energy, which appears as electrical energy, and they are measured in the terms of EMF. So later we are going to see how to measure the EMF, right? That is electromotive force. So in this cell, chemical reaction takes place in the two compartments. Always remember this thing. So in this chemical reaction takes place in the two compartments, each of which is called half cell, and they contain a suitable electrolyte and electrode. So बहुत सिंपल कहानी है, क्या क्या है कि chemical reaction takes place होगा in the two compartment, each which is called half cell, and they contain a suitable electrolytes and electrodes, right? So they contain a suitable electrolytes and electrodes. So always remember this thing, right? Now let's see. So basically in electrochemical or galvanic or we say voltaic cell, the one important thing that is very important to understand is salt bridge, right? So this salt bridge is very important to understand. Basically the solution in the two compartment is connected through a salt bridge. So this is known as salt bridge beta. इसको क्या बोलोगे? Salt bridge. Right. So as its name suggests, this is called as salt bridge. Means they connecting two solution. Right. The solution in the two compartment is connected through a salt bridge. So it is defined as a inverted U-shaped tube that contain a mixture of agar-agar jelly. So in basically K2SO4, they are made up of this salt bridge are made up of electrolyte like KCN, KNO3 or ammonium nitrate. So they all are the inert electrolyte, right? So it is defined as the inverted U-shaped tube that contain a mixture of agar-agar jelly and electrolyte. So इस YouTube shape जो दिख रहा है salt bridge के अंदर क्या क्या होता है? इसके अंदर होता है agar-agar jelly and electrolyte like KCN, KNO3, ammonium nitrate. So they are the inert electrolyte, right? So these are the salt bridge. So I hope is it clear to everyone what is salt bridge and how this electrochemicals look like? Electrochemical cell looks like. So we have a two different container in which two different electrodes are there. In the first container, that is in container number A. In container number A, we have a copper electrode, right? In container number B, we have a zinc electrode, right? And this copper electrode is dipped into the copper sulfate solution, and this zinc electrode is dipped into the zinc sulfate solution. So we have two electrolytes, two different electrodes, which both are separated in a well-separated container, and they are connected through a salt bridge, right? So this is the simple representation of the Voltaic or galvanic cell, right? So what are the significance of the salt bridge? So basically it contains the solution of the two-half cell, thus complete the cell circuit, right? Now it helps in keeping the solution in the two-half cell electrically neutral, right? So इसका बड़ा important है, दो important याद रखो. The first one is it completes the cell circuit. So in questions, they are directly asking the significance or the function of the salt bridge. So always remember this thing. They complete the cell circuit. Second, they make the solution electrically neutral, right? So it helps in keeping the solution in the two-half cell electrically neutral. It provides negative ions to the anodic half solution. Always remember, as we know that the anode is positively charged, right? So they providing negative ions to anode half, and cathode is negative. So for cathode, they providing the positive charge. So they always provide opposite. Why they providing opposite charge? To make them electrically neutral, right? Thus, they preventing the accumulation of extra positive charge in the solution and around anode, which normally hinders the flow of electron from the anode. Clear as sabko? So these are the significance of the salt bridge. Complete the cell, maintain electrically neutrally by providing opposite charges. Anode ko negative, cathode ko positive. Now, what are the characteristics of electrolyte used as a salt bridge? So the electrolyte which is used in the salt bridge, they having also some important characteristics. Like the electrolyte should be inert and should not react chemically with the electrolyte of either of the two half cell, right? So they must chemically inert. They must be, they not react chemically with the other electrolyte of the two cells. The cation as well as anion of the electrolyte should have the same ionic mobility. Always remember this, right? So cation or anion both having the same आयोनिक मोबिलिटी. इसका मतलब है कि जितना टाइम कटायन को लगेगा एक जगह से दूसरी जगह पे जाने पे, राइट, दैट इज द टाइम रिक्वायर्ड फॉर द मूवमेंट ऑफ कटायन फ्रॉम वन प्लेस टू अनदर is exactly same as the time required for the anion to move from one place to another, right? So cation as well as anion of the electrolyte should have the same ionic mobility and almost same transport number like KCl, KNO3, ammonium nitrate, etc. Right? So these all are the characteristics of the electrolyte used as a solvent, right? Now, so Daniel cell is also an example of the galvanic cell. ठीक है? बस इसमें क्या है? When we use only zinc and copper electrode, in ZnSO4 and copper sulfate solution, then this particular cell is known as Daniell cell. So this Daniell cell, galvanic cell, electrochemical cells, all are equal thing, right? Just they having a different name due to the different electrodes. So if we are using only zinc and copper electrode, then they are termed as Daniell cell. Clear, eh? Chalo. So an example of galvanic cell is the Daniell cell. This cell is designed in such a manner to make the use of a spontaneous reaction between zinc and copper ions to produce an electric current, right? So this cell is designed in such a manner to make the use of a spontaneous reaction between zinc and copper ions to produce an electric current, right? So this is the circuit diagram, or we can say that this is the two electrolyte we have. This is a salt bridge and this is the electron flow. Always remember, the flow of current is always opposite to that of flow of electron, right? So if the electron flow from a zinc to copper, then current always the flow from a copper to zinc, right? That is the flow of current is always opposite to the flow of electron. I hope this is clear to all of you. Right. Next, the Daniell cell, basically, the anode is made up of zinc rod and dipped in the solution of ZnSO4. That is also known as oxidation half cell. Similarly, the cathode is made up of copper rod and dipped in the solution of a copper sulfate, which makes the reduction half cell. Now, when the zinc and copper electrode are joined by a wire, the following observations are noted. तो क्या observations noted हो रहे हैं बताओ फटाफट. The observation noted as there is a flow of electric current in the external circuit from copper electrode to the zinc electrode. That is from positive electrode to the negative electrode. This means the zinc rod lost its mass while the copper rod gain its mass. क्यों? Because zinc का oxidation हो रहा है. So due to this oxidation, zinc rod loses its mass and copper rod gain its mass. And the concentration of ZnSO4 solution, because Zn बार-बार Zn+2, Zn+2, Zn+2 में बदल रहा है oxidation करके. So the concentration of ZnSO4 solution increases while that of copper sulfate solution decreases. Clear है? And this is the overall redox reaction that will take place in the case of Daniell cell. I hope this is clear to all of you. सबको समझ आएगा यहाँ तक? जल्दी से एक बार कंफर्म कर दो. Or anyone having any kind of doubt, you can ask. Till all things are clear, or anyone having any kind of doubt, you can ask beta. फटाफट. Yes? No? Everything is clear? Chalo. So this is the overall redox reaction, right? And this is the half cell in which the oxidation occurs. It's called oxidation half cell. Yeah, I got one response here. Understood. Very good, right? So this is the final reaction of the, or we say, overall redox reaction. Clear? Hai? So this is the overall redox reaction of this Daniell cell. Now, these three important cases occur in this Daniell cell. And from these cases, in previous year, in J 2021, questions are directly coming from this topic, right? So this is very important. So all of you, please focus, right? Isko samjho dhyan se. Whenever the external EMF is equal to EMF of the cell, remember this thing. When the external EMF is equal to EMF of the cell, the reaction will stop and the current become zero. As we see in the diagram A, right? So in diagram A, we can see that when the external voltage and EMF of the cell both are equal, right? When the external voltage also become 1.10 volt, the cell reaction will stop and current becomes zero, right? Now, when the external voltage is less and the EMF of the cell is more, the cell reaction takes place. As you see in the figure B, right? In the figure B, we can see that in this, the cell voltage is more as compared to the external voltage, right? So we can say that if the external voltage is very less than 1.10 volt, then the cell reaction takes place. As we can see that the electron flow from the anode to cathode and current flow from the cathode to anode. That is from positive to negative. That is from copper to zinc, right? So electron flow from zinc rod to the copper rod, and the zinc dissolve at anode and copper dissolve at cathode. Always remember. Now, this is the third case. When the E external is greater than EMF of the cell, then current will flow. Yes, then current will also flow, but in opposite direction, right? Now the direction is reverse. Always remember. So when the E external is greater than E cell, the current will flow in the opposite direction. And the chemical reaction of the cell is just reversed like this, right? So in this, we can say that now here, the external voltage is greater than 1.10 volt. So what happened? Now the electron flow from the copper to the zinc rod and current flow from zinc to copper rod. Now zinc is deposited at zinc electrode and copper is dissolved at copper electrode. Always remember this thing. Here, zinc is dissolved at anode and copper is deposited at cathode, right? Zinc is dissolved at anode. Here, zinc is deposited at the zinc electrode and copper is dissolved at copper electrode. So always remember this thing, right? So let's do one question. Before this, I special note that is the electrochemical cell may be reversible or reversible, right? So it is reversible when exactly equal and opposite external EMF is applied or by any other means the chemical reaction is reversed. Clear? So this is the question that this question coming in 2023 means. So can anyone tell me the correct answer for this question? Anyone? Consider the following cell. We have external voltage and here the voltage is also given. So we can calculate the EMF of the cell. How will you calculate the EMF of the cell beta? That is E cathode minus E anode. Right. Later we are going to study this thing as well. I hope you all know this thing. How to calculate the standard EMF of the cell. That is E cathode minus E anode. So which one is cathode? We know that copper is cathode. So this is 0.34 minus 0.76. So this comes out to be 1.10 volt, right? And the external voltage. So identify the incorrect statement from the option given below. So you have to identify the incorrect statement. Can anyone tell me the correct answer for this? JNV गांधीनगर बच्चों ने बोला है C. Okay. Anyone else? जो कुछ और बोलना चाहता है? Yes. JNV गांधीनगर ने सी बोला है. इसके अलावा कोई बच्चा और कुछ बोलना चाहता है? Any other option than C? थोड़ा सोचो. Yes. Yeah, I got two responses. JNB दाहोद ने डी बोला है. माही सागर से ए. JNB पुणे बी. JNB जोरत डी. ओके. सो अलग अलग आंसर्स मिल रहे हैं सबके. कोई ए, कोई बी, कोई डी, कोई सी. तो सभी बच्चों ने लगभग सारे ही ऑप्शंस बोल दिए. So let's see the correct one. Because in this question, they are asking incorrect statement, not the correct one, beta. So they are asking incorrect statement from the option. Okay, here the E cell is what? E cell is 1.10 volt. This is clear. Now, if the E external is greater than 1.10 volt, which case is this? Which case is this, beta? This one? When the external voltage is greater than the EMF of the cell, this case is happening now. So in this case, what happened? Zinc is deposited. Electron flow from copper to zinc, and zinc is deposited at zinc electrode, and copper dissolved at the copper electrode, right? So ध्यान से देखो option A को. Now in this, if the E external is greater than 1.1 volt, zinc dissolved at zinc electrode. No, zinc deposited at zinc electrode and copper dissolved at copper electrode. Right? And if the E external is equal to 1.1, no flow of electron. This is very much correct. If E external is greater than 1.1 volt, electron flow from copper to zinc. This is also true. If E external is less than 1.1 volt, then the zinc dissolved at anode and copper deposit at cathode. This is also correct. So which one is the incorrect? That is option A. So जिन बच्चों ने भी option A बोला, right? Those who say the option A is correct is absolutely correct, right? उनका बिल्कुल सही है. और जिन बच्चों ने B, C and D बोला, बेटा थोड़ा सा ध्यान लगा के देखो इसको, है ना? The correct answer is not B, C and D. The correct answer is A, because in this question they are asking identify the incorrect statement, not the correct statement. Now this is clear to everyone, right? Sure. So this is the representation of the galvanic cell. We all know this. This पे ज़्यादा time waste नहीं करेंगे. We all know how to represent the galvanic cell. So first of all, you have to name the metal and the metal ion, their concentration, and the metal ion.
Cannot hear the sound.
Yes, JNB Mukhala, you want to say anything? Oh, chalo. So the anode side of the cell is represented by writing metal or solid phase, and the cathode side is represented by writing its electrolytic and then the metal in the solid phase, right? And the metal and cation are separated by the semicolon or by a vertical line. So this is how will you represent the galvanic cell. This is the anode side. This is known as anode. Anode. This is the bridge. And this is the cathode. So always remember ABC. A, B, and C. So A is known as anode, B is for bridge, and C is for cathode. So this is how will you represent the galvanic cell. Now, representation of galvanic cell, basically the concentration of the electrolyte is also written within the bracket after the cation, right? Salt bridge which separate the two half cell is represented by the two vertical. Clear? Now, we have a different types of electrode as well. So we have a different types of electrode like inert and attackable electrode, anode and cathode, positive and negative electrode, reversible and irreversible electrode. So we have 4 different kinds of electrode. What is electrode basically? So electrode is a material which conduct electricity to form cell due to the movement of electrons. Always remember. So electrode is the material which conduct electricity to or from cell due to the movement of electrons. It may be taken in form of like wire, rod, and seed. An electron may be classified as inert and attackable electrode, anode and cathode, positive and negative electrode, reversible and irreversible electrode. Clear? Hai? Now, the important topic is electrode potential. So how will you measure the electrode potential better? So basically, electrode potential is measure of the tendency of an electrolyte to gain or lose electron in the half cell. Always remember, right? So what is electrode potential? Electrode potential is the measure of the tendency of an electrolyte to gain or lose electron in the half cell, and it is generally represented by E, right? So this is how we can write the oxidation potential, and this is for the reduction potential. So this is the oxidation potential. Oxidation means lose of electron. So if this metal which is in solid form, they lose 2 electron, or we say n number of electron to form Mn plus ion. Similarly, this in reduction, this metal accept this any electron to form metal solid, right? So such electrode basically, wait. Yeah. So such an electrode is positively charged with respect to its salt solution. So always remember E of oxidation we can write as minus of E of reduction. Clear? Eh? Now, the important term is standard electrode potential. So always remember what is the standard electrode potential, beta? What do you mean by this term standard electrode potential? So basically the potential difference developed between metal electrode and solution of its ion of unit molarity at 1 atm pressure. So always remember at standard condition. The electrode potential at standard condition. What is this standard condition? That is the concentration supposed to be 1 molarity, pressure supposed to be 1 atm, and temperature supposed to be 298 Kelvin. This is called the standard electrode potential. So the standard electrode potential is denoted by E naught. That is the standard electrode potential of zinc electrode, right? So we can denote this like E naught Zn2 plus. So always remember this symbol, that is this naught symbol is used for the representation of standard electrode potential. Clear? Eh? Now, the measurement of the absolute value of the electrode potential is not possible for the single electrode, right? So for the single electrode, the measurement of the absolute value of electrode potential is not possible. So only the difference of potential between these two electrodes can be measured experimentally. So always remember this thing, very important. The measurement of the absolute value of electrode potential is not happen at even not possible for the single electrode. Only the difference of potential between the two electrodes can be measured. फिर तो समस्या हो गया, कैसे measure करें फिर? So we need one sample or demo electrode whose electrode potential are supposed to be known. Then only we measure the electrode potential of the unknown electrolyte, right? Because only the difference of potential between the two electrodes can be measured. So how this we are measured? We measure only when we know or when we have some standard electrode whose potential is known, right? So it is due to the reason that oxidation or reduction cannot occur alone. Oxidation and reduction always occur simultaneously, right, at the same time. So how will you measure the electrode potential? So for indirect measurement of the potential of an electrolyte, we couple the electrode with the another electrode whose potential is known. So this is very important point. So for the indirect measurement of the potential of an electrode, we couple the electrode with the another electrode whose potential is known. This electrode is called reference electrode. So always remember, for measurement of the electrode, we need one reference electrode, right? Clear na sabko? We need one reference electrode, right? Now, as we know the EMF as well as the potential of the reference electrode, the potential of the other electrode is determined, right? Now, some important reference electrode are, so one of the most important reference electron are known as NHE and SHE, right? That is the normal hydrogen electron, and the SHE, that is the standard hydrogen electron, right? Sure. So basically, hydrogen electrode is the primary reference electrode as it is used normally to know the electrode potential of the half cell of the galvanic cell. The reason for such usage is that it can act as cathode as well as anode with other electrode due to the following reasons, right? So hydrogen having capacity, here they can act as a, right, they can act as a cathode. Here they accept this 2 electron to act as a anode, right? So the electrode potential of NaH is taken as 0. So always remember this thing. The electrode potential of the normal hydrogen electrode is always taken as 0. ठीक है? So अगर हमें दो electrode को measure करना है, तो एक को हमने zinc, for example, we have a zinc and we want to measure the electrode potential of zinc. So what you need to do, just combine this zinc electrode with the NHE, that is the normal hydrogen electrode, and measure the potential. If the potential comes out to be 0.76 volt, negative of 0.76 volt, it means this is the potential of zinc rod only, because the hydrogen rod we already assume their potential is assumed to be 0, right? So the potential of zinc is measured by using the NH. Okay? Now the next one is the standard hydrogen electrode, that is SHE. Okay? So a hydrogen electrode in which the pressure of H2 gas is maintained at 1 atm and the concentration of H plus ions in the solution is 1 molar is called standard hydrogen electrode. Right. Now the EMF of SHE is taken as 0.00 volt at all temperature. Always remember this thing. Their EMF is also taken as 0.00 volt at all temperature. Okay? Now, this is how a standard hydrogen electrode look like. So we have a 1 molar of HCl solution, and this is the finely divided platinum coated on the platinum foil, right? And here we can provide a hydrogen gas at the pressure of 1 bar. So this is how SHE is made up of. So remember this thing, beta. What you need to remember, that is the use of SHE is not convenience, right? The use of SHE is not convenience because it is difficult to maintain the concentration of H plus ion as 1 molar and the pressure of the gas is 1 atm. So it is very difficult to maintain the concentration of H plus ion to 1 molar and the pressure of the gas to 1 atm. Hence, it is a common to use a Calomel electrode as the reference electrode. So we can use also a Calomel electrode. Always remember this thing, right? Calomel electrode as the reference electrode. So what is the Calomel electrode, beta? So it is another generally used reference electrode, but it comes in the category of secondary reference electrode, right? What is the secondary reference electrode? The primary reference electrode is the SHE, that is standard hydrogen electrode. So they are known as a secondary reference electrode. In this electrode, a paste of mercury and the mercurous chloride is placed at the bottom of the tube. Over this paste, KCl solution is filled and the glass sealed platinum wire is used for the electric current. The potential of the electrode depends upon the KCl solution, right? So what is the potential of the solution? It totally depends upon the KCl solution. Clear hai? Chalo. On the basis of the concentration of KCl, the Calomel electrode is named differently. If the KCl solution is saturated, electrode is called SCE, that is saturated Calomel electrode, right? So on the basis of the concentration of KCl, the Calomel electrode is named differently. So if the KCl solution is saturated, then the electrode is called SCE, that is saturated Calomel electrode, right? So this is all about the reference electrode. So already studied 3 type of reference electrode. That is the NHE, right? That is normal hydrogen electrode, and the SHE, standard hydrogen electrode, and the Calomel electrode for measuring the electrode potential by using a reference electrode, right? Now, what is the EMF of the cell basically? So we all know that this is a very simple thing. You all know, I guess. Electrochemical cells, the electrode in the different half cell have the different reduction potential, right? As the result of this, different flow of electron is seen from the electrode with the higher tendency to lose electron to other electrode. This difference in electrode potential of electrode is called EMF of the cell. Right. And we know that the reduction occur always at cathode and the oxidation occur always at anode. Therefore, we can write that these 3 different formula for calculating the EMF of the cell. For example, EMF of the cell is defined as the reduction potential of cathode minus the reduction potential of anode. We can also write the formula for EMF as oxidation potential of anode plus reduction potential of cathode, or oxidation potential of anode minus oxidation potential of cathode. So this is the formula for calculating the EMF of the cell. Generally, we use this first formula, right? EMF of the cell is the reduction potential of the cathode minus the reduction potential of the anode. Clear? Hai? Now, we have a very simple question based on this. So, can anyone solve this question? This is a very simple question. This question comes in the NEET 2022 paper. So this is one of the very simple questions. Can anyone try to solve? फटाफट जल्दी से within 1 minute. Everyone try to solve this question within 1 minute. फटाफट, आई एम वेटिंग फॉर रिस्पॉन्सेस. जल्दी से सॉल्व करो फटाफट. विदिन 1 मिनट सबके आंसर आने चाहिए. यस, सबके आंसर आने भी लगे. यस, ओके. सो जेएनवी वेलोर ए, जेएनवी बहरोच ने भी ए बोला है. वेरी गुड, वेरी गुड. सबने ए बोला है. जेएनवी भावनगर, जेएनवी चरणगांव, सबने ए बोला है. वेरी गुड. So many of you say that is option 1 is correct, right? So yeah, कशिश ए, जेएनवी सिमोगा ने भी ए बोला है. वेरी गुड. धानश्री ए, जेएनवी गांधीनगर ने भी ए बोला है. वेरी गुड बेटा. राइट. सो सभी बच्चे ए बोल रहे हैं. फटाफट देख लेते हैं इसको एक बार, है ना. आंचल ने भी ए बोला है. गुड. चलो. सो why option A is correct, right? Why option A is correct? Because we know that how will you find the EMF? EMF of the cell is nothing but is equal to standard electrode potential of cathode minus standard electrode potential of anode. यही तो होता है भाई. ठीक है. सोनाली ने भी बोला है A. Very good. So this is standard electrode potential of cathode, standard electrode potential of anode. So this is how we can find the EMF of the cell, right? Okay, very good. So we have a cathode. So which one acts as a cathode? We know that this one, right? That is 1.33. Always remember this beta. Those having the more electrode reduction potential value, they are always known as cathode. Always remember this thing. So here we have a 1.33 volt. Here we have a minus 0.44 volt. So always, if you want to identify which one acts as a cathode and which one acts as an anode, always look the highest value. So those having the highest reduction potential value, they are always termed as cathode. They are always known as cathode. So here the value of cathode is 1.33 volt, right? Minus 44 volt. So answer comes out to be 1.77 volt, right? So this is the correct. That is option A. ठीक है, तो सभी ने सही बोला. बहुत सिंपल क्वेश्चन था ये. Now let's see some important points for the EMF, right? So what are the important points for the EMF, beta? So if the two half cell are selected randomly for the purpose of constructing a galvanic cell, then on comparing the reduction potential of the two electrodes, the electrode whose reduction potential has greater positive values is made cathode and other is made as anode. So ये भी मैंने बताया तुम लोगों को कि those having the higher reduction potential positive value is made cathode and other electrode is made as anode. Now, constructing the cell in this manner will always give a positive EMF. Otherwise, sometime if the electrode is chosen wrongly, then the EMF will be negative, which is not possible, right? So if the EMF is negative, then it's not the spontaneous cell, then the cell does not work, right? So always remember the reduction potential has a greater positive value. जिसका भी reduction potential ज़्यादा हो, greater positive value ho, they always term as cathode, and those having the lowest electrode potential is termed as anode, right? So these are the important points for the EMF. Clear hai you? Chalo. Now, if the EMF of the cell is positive, the cell is said to be spontaneous or feasible or exergonic. That is delta G is less than 0, right? That is negative. So if the EMF of the cell is positive, the cell is said to be spontaneous. We know this thing now. In our 11th class also we study this thing. Whenever the delta G is negative, gives free energy, then the reaction is said to be spontaneous, right? So if the EMF of the cell is positive, the cell is said to be spontaneous or feasible or exergonic, right? If the EMF of the cell is negative, if the EMF of the cell is negative, the cell is said to be non-spontaneous or non-feasible, or we say androgenic, right? That is delta G is greater than 0. Now, reduction potential is taken as the standard potential. If the electrode potential is given and nothing is mentioned, where it is oxidation or reduction, it is taken as the reduction potential by default. Always remember. ठीक है, अगर दो वैल्यूज कभी भी गिवन है and they are not mentioning whether the value is of reduction potential or oxidation potential, always assume by default the value given is reduction potential value. ठीक है, तो ये always आपको assume करना है, the given value is of reduction potential. Clear hai? Now, one important question is also there. Can anyone try to solve this question? At 298 Kelvin, the standard electrode potential of copper plus 2 to copper, Zn plus 2 to Zn, Fe2 plus 2 to Fe, and Ag plus 2 Ag are given. On the basis of a standard electrode potential, predict which of the following reaction cannot occur. So you have to identify beta which of the following reaction cannot be occur. Cannot be occur means you have to find for which EMF of the cell comes out to be negative, right? For those cell in which EMF of the cell is negative, this cell won't work, right? The reaction cannot occur, है ना? तो फटाफट बताओ इन सभी चारों में से ऑप्शन ए बी सी डी which for which EMF of the cell is negative. ठीक है, ये मैंने हिंट दिया है. EMF of the cell negative means what? The cell is not work. ठीक है, सेल वर्क नहीं करेगा. तो on the basis of a standard electrode potential, predict which of the reaction cannot occur. कौन सा रिएक्शन नहीं हो सकता बेटा इसमें? जल्दी. I am giving you 1 minute for this question. Try to solve this question within 1 minute. We have electrode potential value. Just find for which EMF of the cell is negative. Yeah. Replies आने लगे. कशिश ने बोला है D. Okay. Anyone else? सभी लोग सॉल्व करो बेटा फटाफट. JNV राज को D. बाकी सभी कहाँ गए? आंचल ने बोला है डी. ओके आंचल. अभी तक 3 रिस्पॉन्सेज आए हैं, तीनों ने डी बोला है. मानसी, बैबवी, डी डी, वेरी गुड. रशिका ने भी डी बोला, गुड. चलो, जेएनवी सिमोगा ने भी डी बोला. तो ज्यादातर बच्चे सभी डी आंसर्स बोल रहे हैं. क्यों डी सही है? आज फटाफट चेक कर लेते हैं. अगर मैं डी की बात करूं तो हेयर वी हैव कॉपर, कॉपर एंड एजी, राइट? So for copper, the value is given. What is the value for the copper to copper? Yeah, the value is given, that is 0.34 volt, right? And for Ag plus to Ag, reduction potential is given 0.80 volt, right? 0.80 volt. So which one act as a cathode and which one act as a anode, beta? फटाफट. D, very good. So for which they are act as a cathode and anode, फटाफट बताओ. Here copper plus 2 to copper, copper plus 2 to copper, the value is given. The value is 0.34 volt. Here also this value is from Ag plus to Ag. The value is given, that is 0.80 volt. So we know that what is EMF of the cell. So EMF of the cell is nothing but E cathode minus E anode. Okay. Okay, Ag cathode ना, good. So ये हो जाएगा 0.80 माइनस क्या होगा? 0.34. 0.80 माइनस 0.34, राइट? एनीवन? ऐसे क्या है सबने? फटाफट जल्दी से बताओ, सबने ऐसे ही किया है? डन. सो इट्स अ वेरी सिंपल क्वेश्चन, राइट? सबके लिए निकाल के देख लो. अगर आप इसके लिए निकालो कॉपर, जिंक, ZnSO4 एंड हेयर कॉपर ऑल्सो, So this is copper and zinc. So copper having value given at 3.4, zinc का 0.76. कौन कैथोड होगा? कॉपर कैथोड होगा. So this is 0.34 minus and this is minus 0.76. Right? So this comes out to be calculate कर लोगे. That is 1.10. सबके लिए कैलकुलेट करो. ठीक है? तो जैसे सबके लिए कैलकुलेट करोगे you get the value. ठीक है? चलो. Now the second important thing is the electrochemical series, right? So what is this electrochemical series? So basically the arrangement of metal in decreasing order of tendency to lose electron is called electrochemical series, right? So it is the series in which the elements are arranged on the basis of their standard reduction potential values, right? So the arrangement of metal in decreasing order of tendency to lose electron is called electrochemical series, or it is the series in which the elements are arranged on basis of their standard reduction potential values. So this is the series, right? So just observe this series very carefully. If we move upward, right? If we move upward, then we can say that reducing property increase, right? So on moving upward, we can see that reducing property, reducing character increase, reducing character increases, right? So on moving upward, reducing character increases, and on moving downward, oxidizing character increases, right? Similarly, on moving downward, we can observe that the reduction potential value is more and more positive. So we can say that on moving downward, reduction potential, that is reduction potential values increase. So reduction बढ़ेगा और ऊपर जाओगे बेटा तो क्या बढ़ेगा? ऑक्सीडेशन बढ़ेगा, ऑक्सीडेशन. ठीक है, ये चार चीजें याद रखो. फॉर इलेक्ट्रोकेमिकल सीरीज हाइड्रोजन के लिए वैल्यू कितनी है बेटा? 0 है. ठीक है, एक तरह का बैरियर का काम कर रहा है. हाइड्रोजन के ऊपर जितने भी हैं दे ऑल हैविंग द नेगेटिव वैल्यूज, राइट? और हाइड्रोजन के ऊपर नीचे जितने भी हैं सबकी वैल्यू क्या? पॉजिटिव. एंड अबव हाइड्रोजन ऑल हैविंग द नेगेटिव वैल्यूज. So as we move from hydrogen to lithium, they are reducing character increase, or we say they are oxidation potential values increases. Similarly, when you move below hydrogen, then we can say that their oxidation, their reduction potential values increase, and their oxidizing nature also increases. ठीक है? So बस इतना ध्यान रखना है तुम लोगों को इलेक्ट्रोकेमिकल सीरीज से. ठीक है, एक क्वेश्चन ले लेंगे अभी फटाफट. So the negative sign of standard reduction potential indicates that the electrode when joined with the SHE behave as the anode. Similarly, the positive sign of standard reduction potential suggests that the behavior of electrode as cathode when joined with SHE. ठीक है, तो जो भी बात बोला है वही डिस्कस किया है यहाँ पे. So what are the characteristics of the electrochemical series basically? So element which get oxidized easily are the good reducing agent, that is the metal, and the element which get reduced easily are the good oxidizing agent, or we say non-metal. A metal with a lower SRP, that is the lower standard reduction potential, can have the ability to displace metal with the higher SRP from the solution. Secondly, the reactivity of the metal. इसका मतलब क्या बोल रहा था ये मैं समझाऊं कि अगर तुम ऊपर जाते हो हाइड्रोजन के ऊपर, so Fe having tendency to replace the cadmium. Similarly, sodium having tendency to replace all magnesium, aluminum, and zinc. Lithium having tendency to replace all of this, that is potassium, calcium, sodium, magnesium. So as we move upward, they are lower reduction potential value, having capacity to displace this, right? So metal with the lower SRP can have the ability to displace metal with the higher SRP from their solution. ठीक है. Secondly, the reactivity of the metal decrease from top to bottom in the electrochemical series. Metal higher in the series are more reactive, more active than the metal lying lower in the series. ठीक है. Now, one important question, एक यहाँ पे भी question बना है. Identify the incorrect statement. So you all have to identify the incorrect statement बेटा. मैं इसको थोड़ा सा बड़ा कर दूंगा, रुको थोड़ा सा बड़ा कर देता हूं, सबको दिख जाएगा. चलो, so all identify the incorrect statement. सबको एक incorrect statement पहचानना है इसमें, फटाफट जल्दी से. All of you identify one incorrect statement. It is totally based upon the electrochemical series. Yes, I'm waiting for a reply, guys. फटाफट बताओ जल्दी. We have a reduction potential na, AL to AL 0.55 volt, AL plus 3 to AL 1 minus 1.66, TL plus 2 TL minus 0.34 volt, and TL, this is TL beta, right? This is TL. TL plus 3 to TL, that is plus 1.26. So identify the incorrect statement. We know that higher the negative values, more in reducing property. Greater the positive values, more in ऑक्सीडाइजिंग प्रॉपर्टी. तो आइडेंटिफाई फटाफट जल्दी से. जो जितना नेगेटिव होगा, राइट, जो जितना नेगेटिव होगा वो उतना अच्छा रिड्यूसिंग कैरेक्टर शो करेगा. जो जितना पॉजिटिव होगा वो उतना अच्छा ऑक्सीडाइजिंग कैरेक्टर शो करेगा. सो विच स्टेटमेंट इज इनकरेक्ट? कौन इनकरेक्ट है इसमें? फटाफट आइडेंटिफाई करो. Which statement is incorrect? बताओ. Yeah, I got one reply. That is D. Okay. TL can be easily oxidized to TL plus 1 and TL plus 3. Okay. कोई और? ये क्या है भाई? बी. देखो, TL plus 3 is a good reducing agent. TL plus 3 is a good reducing agent कैसे हो सकता है? Because TL plus 3 के तो पॉजिटिव वैल्यूज है. So TL plus 3 is good reducing agent than TL plus 1, right? Yes, Jeremy Dadot ने D बोला है. So TL plus 3 is a good reducing agent than TL plus 1. This is true. TL plus 1 3 के लिए वैल्यू तो पॉजिटिव है, तो गुड रिड्यूसिंग एजेंट कैसे होगा? गुड रिड्यूसिंग एजेंट तो जब होता ना जब वैल्यूज नेगेटिव होती, राइट? गुड रिड्यूसिंग एजेंट कौन है? जिनकी वैल्यू हाई, जितनी ज्यादा नेगेटिव है. So TL plus 3 is a good reducing agent than TL plus 1. TL plus 1 we have value minus 34 and TL plus 3 we have value plus 1.26. So TL plus 3 is a good oxidizing agent, ना कि good reducing agent. That's why option B is incorrect, right? So that's why option B is incorrect. So ये है option जिसके चलते option B क्या है बेटा? Incorrect है, right? समझ आया सबको क्या? Everyone got it? Right? Got it? Chalo. So this is all for the today class. In the next class also we are going to do numerical on the basis of Faraday laws, electrolysis and the electrolytic solution, right? So try to revise this as much as you can and try to solve numerical related to this chapter, right? So we have also one in tomorrow class also we are going to solve some question related to the electrolytic conductance and Faraday laws, electrolysis, right? So till just revise this concept and try to solve more and more questions. Anyone having any kind of doubt, you can ask. No? चलो ठीक है. So meet कल मिलते हैं and tomorrow we are going to solve some more question related to this chapter.